Hi, my name's Nick, and in this video I will show you how to use Tufts University's ROS for LabVIEW add-on to control a Clearpath Husky from a computer running LabVIEW. So this tutorial basically goes over a tutorial that was made on the Clearpath website. Here's kind of a little view at the tutorial. It goes through and it explains to you how to install ROS for LabVIEW, how to install the add-on, a quick overview of the buttons that are available, and then it actually goes through and tells you exactly how to set everything up. So you have to make sure that all the computers can communicate together. And then finally it goes through and explains how to drive the Husky with LabVIEW, how to build the actual VI that will do that. And then it shows you how to install the VIs that Clearpath has made for doing this, for driving the Husky, as well as for subscribing to certain topics, including the odometry, the filtered odometry, as well as laser scans. So that a link to this tutorial will be posted in the video. So here on my left here, the left screen here, I have a computer running Ubuntu 14.04 with ROS Indigo. And on my right here, I have a Windows computer which will be running LabVIEW 2014. So to start off, I'm just going to open up a blank project. I've already installed the add-on onto this computer. I've done it two different ways to kind of show you both ways that you can do it. Basically, you can install it from source. There's a GitHub repository for that. That will also be in that tutorial on Clearpath's website. You can also install it from the package manager, which is, again, it's all explained in that tutorial. So starting off, I'm going to open up a new VI. And go into my block diagram. If you right click and go onto add-ons, so if you've installed from the package manager, your ROS for LabVIEW VIs will be in your add-on section here. So if I pin that, you can see there's a bunch of different VIs that are created to do a bunch of different things. I will go through some of these in this tutorial. There's lots to go through, so I'm not going to go through all those right now. There's also a bunch of VIs for different devices, including the Baxter, the ROS Rio, Turtlebot, as well as the VIs to control the Husky, which are available for download. You can also put in your library that contains all these VIs if you want to actually be able to access them from here. So let's close this. If you installed it from source, you can go down, right click here and go to user libraries, and it should be right here. So closing this, I've also installed the whole GitHub repository that has the VIs for Clearpath Husky. Let's not save that. Open existing. So that's all in here. So it comes with the Control Husky project file, which has the odometry subscriber, laser subscriber, laser and odometry subscriber, and yeah, so the odometry subscriber, the laser and odometry subscriber, as well as the velocity publisher, and two separate VIs for parsing different types of messages. So I will go through that once I get to that. Starting off with the velocity publisher. In the Clearpath tutorial, it goes on in significant detail how to make this actual piece of code. So I'll open up the block diagram. Here's everything that's available here. So quickly, just to go through it, and again, I suggest that you read the tutorial on Clearpath's website. It explains what all these are doing, but ultimately you have a ROS topic initiate node, or VI. This actually creates your node in ROS and allows you to start then publishing topics or messages to certain topics. So here you define the properties of your node. So this is the topic that I'm going to be publishing to. This is the type of messages, publisher, or you could select subscriber or client, queue size, and I believe this is update rate. And then here you provide the name of the node that you want to actually create. The other big thing is the ROS topic write. So here you've just initiated the node, and here it's actually writing to the node. So you can see that's in a while loop, which also has another case structure here. So I can stop publishing and start publishing without leaving this while loop. So this is going to continuously publish twist messages here, which this is the message builder, which has already in the add-on by Tufts University. And then the last big part of it is the ROS topic close. This is very important because you have to basically close your node, or else you can have some floating nodes if you shut this down and don't actually close the node. Then when you go to re-initiate a new node, you might have some problems. Another thing, because if you notice that our stop button here, which is this end node here, control is inside this while loop. So if we end the program with the stop button here and we do not press this end node, then it will end the program without exiting the loop, and it will not close your node, which will also give you problems. So make sure you do that every time. So if you look over to the computer here running ROS, I'm just going to start up Gazebo. So if you do ROS launch, Husky, Gazebo, Husky, and let's do playpen.launch. So first I'm just going to show you how to control, not sure what happened here. Try that again. Okay, not sure why that happened. Anyways, here at first I'm just going to show you how to run it in simulation. Then I will actually show a video of this actually working on a real Husky and driving the Husky around in LabVIEW. So here we just have just a Husky in simulation in the playpen world. It has a LiDAR on it, so you will see. I will show you how you can actually see those messages in LabVIEW. So quickly just showing how this velocity publisher works. If I run the command here, you'll see nothing is happening. First off, because I haven't actually typed in any velocity commands, but also the stop and start publishing button is off. So it won't do anything till that's on, and that becomes very useful when you're actually controlling a Husky and you want to change your velocity commands. It's better to stop the button, change those, and then continue it. So if I just go 0.3 for linear x velocity, let's go negative 0.3 for our angular velocity in z direction. It's an important note here that if you've worked with TurtleSim or Husky in any way, you can only publish to these two velocity commands: your linear velocity in the x direction and your angular velocity in the z direction. It can't move in the y direction, z direction, or rotate around the x or y. So now that I've set that, I can just hit start stop publishing, and you'll see this indicator here will now show you the messages that are being published. And if we look over in our simulation here on the left screen, you'll see the Husky that starts rotating in a circle. So I can go back to my LabVIEW screen here, stop this, my Husky will stop. I can change this to whatever I want, and then restart this, and it'll continue driving. And that is basically it. So now to stop this, I want to make sure I hit end node. We will exit this loop, close the topic, and we're good to go. So that's the velocity publisher. Also in this project we have Sorry, let me open this back up. Where is my project? Oh, I didn't open up my project. So let me just close all this. Let's open up the project instead of just the individual VI. So here now I have all my VIs already saved in this project. So let's reopen the Velocity Publisher. And I'm going to open up the odometry and laser subscriber. So I won't show the odometry subscriber because it has the same stuff as the odom laser subscriber, just less. And the parse laser scan and parse odometry are sub VIs that are within this odometry laser subscriber. Okay, so let's open these up side by side so we can see them well. Sorry about that. Okay, so here in this, oops, lost it. So here in this VI, you can see we're subscribing to the pose. So this is the Husky EKF filtered odometry. This can have any sort of sensors, any sort of basically SLAM will get you an EKF odometry measurement that you can subscribe to. The scan details are errors to depose, and then it plots your scanning as well as your odometry as you go along. So there's a clear plot button here if your plot's getting too big. This is just basically an example showing you some of the capabilities. Obviously there's a lot more capabilities that you can do with it, but this is kind of a neat example. So if you look at the block diagram, I'm not going to go through it all in detail, but again, we have our ROS topic read ROS nodes here, VIs here. We have a ROS topic initiate. So yeah, the only difference between this subscriber versus the publisher is that now we're reading from topics as opposed to writing to topics. But again, we have to create our nodes that will read these. So here we have a node called LV odom that will subscribe to the odometry filtered topic, which are these type of messages. And then we have a node here called LV scan that will subscribe to the scan topic with these message types. So the parse odometry and parse laser scan, those are the sub VIs that I was talking about that are in the project already. There already are a lot of, so basically just to explain quickly what parsing and message building is, the way that ROS communicates with LabVIEW is that it grabs the messages from ROS, flattens them into a string, and then now you have to extract the information in LabVIEW that you want to use. So that's called message parsing, and going the opposite direction is message building. So you want to build a message that's going to be the right format for ROS to read. So the ROS for LabVIEW add-on has a lot of those already. If you go to here, let me just pin this so I don't lose it. Here's the ROS topic, initiate ROS topic, read ROS topic, write that I was telling you about. And then there's message building and message parsing. So if you just, for example, look at the message parsing, it can parse basically all these types of messages. Someone's already created a parser that will do that for us. So if you do want to subscribe to a topic that has one of these types of messages, you can just directly drag and drop that into your project and it should work fine. However, soon as your message types are slightly different than anything here, you will have to create that on your own. So these here are a good example of things that I had to create for this project specifically. So you can go through those and try and understand what is going on. Maybe I won't go through that now. Tufts University did release a tutorial that explains how to build and how to parse messages. So that will also be in the Clearpath tutorial. You can there'll be a link to it there. I would suggest going through that if you're going to have to build or parse messages, and you can use these as another example. So here we have the scan topic. There's a specific type of laser scan that I want to parse, and then so that outputs my that outputs the range and bearing, and then I want to convert that to X and Y, and then bundle that together and plot that. So that's just some simple math here, and then in there was just some parsing. And for the odometry, again here we're parsing it, we're outputting it into an array or a cluster here, plotting that, output into a cluster, and then we're concatenating it with the last one, and that's continuing the loop and it's continuing to build. So this pose array here will continue to build every time you go through the loop. And then again, once you hit stop, it exits the loop and shuts down those nodes. So it's important to note here that there are some variables at the top that you can change. Your update time for how often it grabs or subscribes to a point and saves that, and then the maximum odometry points that you want to keep till it clears that out. So if you have any problems with your memory while you're running this, you might get some errors that saying you're running out of memory within LabVIEW. You can change these parameters so that you're saving less. Your arrays aren't getting as big. You can also change your type of message that you're saving. Okay, so to show how that works, I'm going to maybe I'll restart. Let me just restart this so that it starts again at location 0. It's going to launch the same exact thing. Okay, so starting off with that same circle that we did before, so 0.3 in the x direction, negative 0.3 in the angular z direction. I'm going to start my subscriber. You should see here that we're starting to plot around 0 there. We can see our laser scan, and now I'm going to start publishing my velocity commands. So you should see, we can see on the left screen there that my Husky is driving in the circle again, and on the right screen we can see the odometry being plotted, as well as the laser scans every time it goes through that loop. So we can clear our plot if we want. Let me just finish its circle first. Goes pretty well near 0 again, with some slight drift, some slight error that builds up. Clear the plot, and it continues again. So again, you can play around with this all you want. Let me stop moving it once it rotates a little bit further. And drive in a straight line again. And that's pretty much it. So remember, I want to hit the stop button to make sure it closes the node, so when we rerun it, it reinitializes it properly. I'm going to stop this as well. And that's pretty much the end of it. Now, afterwards I'll show you how this is done in on a real Husky, which is pretty much the exact same thing. The only difference being that instead of running Husky Gazebo package, I'm going to run Husky base, and then I publish to the exact same topics, the velocity Husky controller slash command velocity, and it will the Husky base will subscribe to that and start moving the Husky. Alright, now I have my laptop hooked up to my Husky. I'm running Husky base on the laptop. Open up my project here, open up the odometry subscriber and the velocity publisher. Move these aside so you can see them. Alright, so I can start this. You'll see that nothing is being published yet on the messages because my start button is still off. I'm going to go over here and run my odometry subscriber. You'll see basically 0 plots. It's not moving. Now set my velocity commands to what we had them as before, or similar to what we had them before, and I'll start publishing. So right away you see on the left the Husky starts to move around in a circle, and on the right here you can see that it's plotting exactly that. It's plotting the odometry that the Husky is calculating. So again, this works the same way as it works in simulation. We can stop this here. Let me just let this finish for a second. Stop that. You'll see the robot stops, and I'm going to change and stop the twist message here. Maybe increase my linear velocity in the X. Start publishing again, and that's it. So thank you very much for watching this tutorial. I hope you learned a lot, and have fun controlling a Husky in LabVIEW.